This is section 2.1, and we're going to talk about representing relations and what relations are and how to actually show them in different ways. So let's start out here with what is a relation? Well, a relation, as the actual definition is, it's a set of pairs of input and output values. Now, if you remember, and this might take a little bit to remember this because it's been a little while for some of you, but if you remember, if I were to write an ordered pair like this, okay, for example, even if I used a number, let's use the number 5 and 3. Okay, if you remember, when we talk about relations, we have input values, output values. A relation essentially is a set of ordered pairs. That might be an easier way to write that down. You might want to write that down. It is a set of ordered pairs. Okay, and the x value, which is usually always, it always comes first in an ordered pair. This is the input. This is what you put into something. Okay, and the y value is the output, or what you get out. Okay, so we have input values and we have output values, and what they're going to do here is they're going to show you 4 different ways to represent these relations. Okay, again, a relation is a set of ordered pairs. Okay, so there's 4 ways that we can represent these relations. One is simply by writing out ordered pairs. Okay, you see here in this is a way to represent relations. You have a set of ordered pairs. You have x, y, negative 3, 4, or 3, negative 1, 4, negative 1, and 4, 3. These are relations. Okay, there's an x value, there's a y value, just like normal. You've seen those before. The mapping diagram is slightly different in that you'll notice you see these 2 kind of oval shape here, and you see these arrows. Okay, the x values, or the input values, always go in the left side of the circles, and the y values, or the output values, always go on the right side of the circles. Okay, so you'll notice here, as you see, they did this for the same exact thing over here. We have, for the x values, we have negative 3, 3, 4, and 4. Here they have just negative 3, 3, and 4, because you don't ever have to write repeat numbers down. You only have to write one of them down. Okay, and then for the y values, we have 4, negative 1, and 3. And again, over here, then they put in the y values in the circle, 4, and then they have a negative 1, and then 3. Again, they don't repeat. Now, you'll notice the arrows show you how to pair up each input and each output. So negative 3 over here goes with the number 4. So negative 3 has an arrow going from negative 3 to 4. That's how you tell. 3 is with negative 1. So 3 has an arrow pointing at negative 1. 3 and negative 1 are together. 4 has 2 numbers. It has negative 1 and positive 3. So 4 has an arrow going to negative 1 and an arrow to positive 3. Okay. The other way you can represent a relation is a set of ordered pair, or excuse me, is a table. And you've done this before as well. It shows it kind of fancy here, but you've seen it as an XY table. Okay, and then you would put your x values on the left side, and then you would match up the x value with what y value goes with it. So in this case, again, you'd have negative 3, and then 4 would be right across from it because it goes with negative 3. Okay, the last way is using a graph, and simply just using a graph, you are just graphing these ordered pairs. So for example, the ordered pair negative 3, 4, remember the first number is the x. That tells you how much left or right you go. The second number is y. That tells you how much up or down you go. Okay, so in this case, to go to negative 3, 4, you would go left 1, 2, and 3. That's left 3. That's negative 3. And then you would go up 1, 2, 3, and 4. Up 4. Okay, that's left 3 and up 4. So you can plot them on a graph. All right, now let's take a look at the example down here that we have. it says here, every year, Rock and Roll Hall of Fame Museum inducts legendary musicians and musical acts to the hall. The table shows the number of inductees for each year. Represent the data using each of the following: a mapping diagram and ordered pairs. So as you look at the list over here, usually it always works out so that the left column is always your X values and the right column is always your Y values. So they've split this up. These are the X's and these are the Y's. Again, the year is the X's and the number of inductees are the Y's. Usually the X's are always either on the left, or if it goes from top to bottom, it's usually on the top. Okay? So let's start with a mapping diagram. We're going to draw two big ovals here. Okay? And what we're going to do is we're going to list out the X values. So as I list out the X values here, make this oval a little bit bigger so we can, there we go, put these numbers in here. We're going to put in the number 2001, that's an X value, 2002, 2003, 2004, and 2005, and 2006. Okay, so we're going to put those numbers there. The Y values we're going to put on the right side. So that's 11, this is 8, that's 9. Remember, I don't have to write 8 twice. I only have to write it once, and then I have 7, and then I have 6. Okay, so now I need to draw arrows from the numbers on the X's that go with the Y. So 2001 goes with 11. So I'm going to draw an arrow from 2001 to 11. 2002 goes with 8. I'm going to draw an arrow from 2002 to 8. 2003 goes with 9, so I go from 2003 to 9. 2004 is going to go to 8, so 2004 I'm going to draw that arrow up to 8 like so. 2005 goes to 7, and 2006 goes to 6. Okay? All right, so this is how you would do the mapping diagram part. Now, the ordered pairs part, I'm simply just going to write ordered pairs. So my first number here is 2001, and that goes with 11. Then it's 2002, that goes with 8. Then it's 2003, that goes with 9. 2004 goes with 8. 2005 goes with 7. And 2006 goes with 6. Okay, now in your class kick, you should be able to complete the first question there for being able to represent with mapping diagram and ordered pairs.